Hi. So last time I asked you to try to do those questions in OneNote, and okay, and ask you to use the PowerPoint in the OneNote to check whether you got the correct answers. So let's have a look quickly. So here are the answers, right? So again, you need to use um, a variety of rules in differentiation. In particular, the new rule you've learned is the differentiation of the exponential functions and also the application of chain rule in the differentiation of that exponential functions. Okay, so here we are. So these are the answers, right? So you see, so hopefully you've done it. So see how many questions you did right. Oh, good. So I'm not going to go into details with you for these three questions. Okay, so I need to move on to example 7. So here's example 7. Okay, so again, you need to find the derivative. Okay, so before we started, so let's have a quick look of the two very important rules for the differentiation of exponential functions. Okay, so let's say the function we are interested in is fx equals e to the power x. So remember when you differentiate e to the power x, okay, you always get the same thing. Okay, so that's the only function the derivative is equals to the function itself. Okay, but there are more variety, so sometimes you will see the function looks like e to the power gx. Okay, so that gx could be anything. Yeah, so that gx could be like e to the power 2x, or it could be e to the power 3x plus 1, or it could be e to the power x squared plus 3x minus 1. So it could be anything. So how could we differentiate such a function? We use chain rule. Okay. So the mechanism for the application chain rule I'm not going to cover again. So the result is when you try to differentiate such thing, you try to create a chain in terms of gx, and so that's the chain rule, right? And the first part of it is just e to the power gx. So essentially, you just rewrite the function again, but you need to multiply that the derivative of the function in the power. Okay, so that's it. So these are two very important rules we learned last time. So let's go back to example 7. So e to the power x squared. So let's highlight a little bit. So that x squared is just what we call the gx here. Okay, so if you apply the rule quickly, then you will have d e to the power x squared dx. So let's just do a slow version, then I will try to give you a quick version, right? So this slower version is like you need to write the chain rule. Okay, you change that dx into dx squared to make sure they match. Okay, then you multiply that dx squared for dx. So that's the chain rule if you are alright with that. Okay, so then you will have ex squared times 2x, and that's it. Okay, so that's possibly the slow version of it. Okay, so how about if you want to speed up the process a little bit, you can do it like, okay, so yeah, sorry. So it's essentially the same, but you just don't need to write the chain rule part of it. Okay, so first of all, you rewrite the function. Then remember to differentiate that x squared. So the derivative of x squared is 2x. Okay, and that's it. Okay, so I will try to use this quick, this quicker version for the following questions. So because possibly that would be easier for me to write the answer, right? So that's the quicker version. But I really want you to understand the chain rule of it. Okay? Okay, but anyway, I'm going to use the quicker version for this one. Okay, so I'm going to do the derivative. So I just write f pi x. So I just want to show you how quick it can be. So you just rewrite that stuff right here. Then you differentiate dx cubed plus 5. How can we differentiate dx cubed plus 5? Okay, remember you apply the power rule. So dx cubed dx 3x squared, d plus 5 is 0. Okay, and that's it. And in the exam, if you write things like this, it's completely fine. It's 100%. Okay. Okay, for this thing, you might want to rewrite that function a little bit because you want to see. All right. Okay, so when I differentiate the whole thing, of course, I'm going to put that 3 out of the operator. Okay, so right now, focus on the second part of it. Okay, so you see, if I use the quick version, I'm going to write, okay, first of all, the function itself. Then I'm going to differentiate that minus x cubed. Okay, if I differentiate that minus x cubed, what I'm going to have, that must be minus 3x squared, right? So, and you of course, you have to simplify your answer. And so we tend to move that x squared and the numbers to the front. It just the conventional way to write the answer. Is that okay? Okay, so after you've done this, I think you might need some time, okay, to tidy up the copying and all sorts of things. So spend 5 minutes to reflect on this example. Okay. So I'm going to turn my fans on. It's really hot in my basement. Sorry. Okay, 5 minutes and I'm back. All right. Okay, still remember there's some applications for the differentiation. So one of the main application of differentiation is that the derivative is the gradient of tangent. Still remember that? Okay, here's the facts. Possibly we need to know. So that's a fact. Okay, so remember derivative is the gradient of tangent at a point. Okay, so what do we mean by tangent? Okay, so let's say if you draw a curve, let's say this is a curve and this is a point. So where's the tangent? What's the tangent? Tangent means a straight line, which, it's really hard to draw a perfect line. I try again. Okay, this one is much better. So this is what we call tangent. Okay, and for this tangent, of course, we are interested to know the gradient of that tangent. And how can you find the gradient? You just need to do the differentiation of the curve. Okay, so the curve right now is in the form of y equal, oh, what's this? Y equals e to the power 2x plus 4. Of course, that e to the power 2x is an exponential function. Sorry. Okay, so what I'm going to do is find the gradient of tangent to the curve at the point. Okay, so there are 2 points given. The first point 0, 5. So I'm going to do the gradient. How can we do the gradient? First of all, if you remember, you need to do a differentiation, right? So, okay. So because we're talking about the gradient, so normally we use m to represent gradient. So m equals dy over dx. Okay, and you just copy that thing there. Okay, so, and there are 2 parts of it. And we all know the second part is 0. How about the first part? So first part is an exponential function, sorry. And so we shall use the quicker way. So just write the function itself times the derivative of 2x, which is 2, right? Derivative of 2x is just 2. Okay, so it's 2 times e to the power 2x. So that's it. But this is the derivative of any x. But you see, they give you a point. So this is the point, 0, 5, which is, of course, on the curve. So if they give you the point, of course, at different points, you will have different gradient, won't you? Okay, so how can we find the gradient at the particular point, like 0, 5? So that's what I'm going to do. So remember now, your gradient equals 2 times e to the power x without specifying the value of x. Now I'm going to specify a certain value of x, which is x equals 0. When put x equals 0, so that gradient. Okay, so I'm going to write a little bit fancy notation. So that's for last year, right? I really like this notation. Just draw a vertical line and put x equals 0. That means right now I'm going to find the gradient at x equals 0. Okay, so that's 2 essentially, because e to the power 0 is 1. Is that okay? E to the power 0 is 1. Okay, so e to the power 0 is 1. Is that okay? Anything to the power 0 is 1. Okay, why? Good. And so that's 2. Okay, so we answer the question for A. Okay, so you say, oh, that's 5. Is that 5 useful? No, you are going to find the gradient, so you don't need that y value. The y value just give you for the sake of completeness. All right, so that's 5 in this case is not useful. You don't need to worry about that. Okay, so how about B? So right now B is another point, so that 2 different points. How can you find the gradient? Okay, I will give you 1 minute. Try to get your answer. The hint is you don't need to do it from the very beginning. You can use the results in previous part. Okay, let me zoom out. You see the previous parts. You've already got gradient in terms of x. How can you get the gradient at x equals 1? 1 minute. Okay, so if you have got it, so you can pause the video. Anyway, I forgot to remind you. Okay, so let's say you've thought that for 1 minute. Okay, so I'm going to write x equal to 1. Then I'm going to write that m equals d. I really like that fancy symbol, although I don't really need to write that thing here. Okay, so that's 2 times 1, so that's 2 times e squared. So that's it. That's the answer. So, and you would say, oh, then what would be the E square? Okay, so if that's paper 1, then you don't need to worry about this. If that's paper 2, then you just use your calculator to get E square, and times 2, you get the decimal number. I think that would be a paper 1 question anyway. Okay, so here are some chain rule problems. Okay, I will go back to show you some of the questions I would like you to do as homework. Right now, I just continue on Porter rule. Okay, still remember the Porter rule. Okay, so let's go back to the Porter rule a little bit earlier. Okay, here's the Porter rule. Okay, Porter rule means you have a function which can be expressed in terms of the product of two parts. And when you differentiate, you follow that rule. Okay, so this rule you need to know its existence, and you need to know when you need to use it. Okay, that's very important. Whenever you see that two things multiply together and both things are not constant, then you need to use that Porter rule. Okay, so remember when you apply Porter rule, you have to do differentiation on each part, while the other part just multiply the derivative of its partner, right? Okay, so here's the rule. If you need some time, just pause the video to go back to see that again. Porter rule is so important. Okay, so let's go to this part. Okay, how can we apply the Porter rule? Because we can see that two parts of it. So that two parts. One part is e to the power x, the other part is 2x plus 1. Okay, so let's just say u equals e to the power x, and also my v equals 2x squared plus 1. Okay, so when I differentiate this whole thing, what I'm doing is actually times u times v. Okay, then I just copy everything. But you have to make sure you have that's Porter rule correct. Okay, so this is, again, let me say it again, Porter rule, very important. Okay, and v is 2x squared plus 1 dx. Okay, let me just try to do it like that. Okay, so how about the first part of it? Okay, remember you put 2 out, 2 dx squared. Okay, and the second part of it, anyway, I'm just... Okay, so how about that? Dex over dx, which is just ex. And I'm going to simplify this a little bit. Okay, so remember this is 2x plus 0 plus 2x squared plus 1 e to the power x. Okay, so if you feel I'm doing so quick, you just pause the video and slow it down. That's the advantage of watching a video. Okay, so that becomes 4x. Oh, sorry. So, sorry, it's really annoying. Okay, that's 4x times ex plus 2x squared plus 1 bracket ex. Okay, so let's see if there are some common factors. Yes, you see this is e to the power x, e to the power x. So these are the common factors. So I'm going to take the common factor out of it. And that's 2x squared plus 1. That's it. Well, you might want to rewrite that ex to the right-hand side. Is completely fine. Okay. Yep. So hopefully I didn't make any mistake. All right. If I make any mistake, just go to check PowerPoint. The answer in PowerPoint is correct. I'm just a bit slack. I don't want to check it again. Okay. Oh, good. And yes. So if you're okay with that, let's try another one. Okay. So this one, you need a little bit revision on the chain rule for the Porter rule. Okay. So again, for this one, I'm asking you to use that Porter rule again. Okay, so I will allow you to spend 5 minutes. Try to do as far as you can. Okay, but the tricky part is that square root thing. But I really want to see how much you can do. Yep. Okay, let me pause the video again. Oh, sorry. Okay, so let's come back. All right, so after 5 minutes, how much we've done? All right, let's say in this case, all right, so I'm going to use another color. Use, how about blue? I'm going to use u equal e to the power x and v. Okay, so just for this one, I'm going to think about how can I differentiate that's v. For v equals x minus 1, the whole thing's taking square root. What you're going to do is you can is appreciate the fact that you have to use chain rule. If you can't see how chain rule works for this one, then possibly you need to do more work on chain rule. So you really need that one. Okay, so you see you must have the same base before you can use the power rule. I think most of you should have used it. Okay, so that's the power rule for this part, but you must make that x minus 1 as the base first. Okay, I hope you understand this one. All right, so that actually becomes minus half. Okay, so that's pretty much the v dv dx, and u is much easier. It just itself. Okay, and okay, so the whole thing, how can we present the whole thing? So let's write this one. Okay, so let's just say this is u times v dx because okay, and that's the chain rule. So no, that's the Porter rule. And Porter rule means, okay, so how about that dv dx? dv dx is just half. Okay, half times x minus 1, the whole thing to the power minus half, plus v. V is just this guy, right? Times du over dx, ex. Remember, we've done the du over dx and dv over dx, okay, before we apply the whole Porter rule. Okay, after you've got that, and you will have ex. Okay, be careful that x minus 1 to the power minus half is just 2 right here times x minus 1, because half of the power means square root. 1 over it means, okay, 1 over a square root of the whole thing. And you would like to write that thing like this. Okay, I think that's it. If you want, if you think taking out e to the power x is better, then it's up to you, but it's not necessary in this case because that's complicated enough. Sorry, that's simplified enough. All right, so here is the thing. Let me track the PowerPoint. Do we have the same answer in PowerPoint? Uh, sorry. Let's, yeah. So that's pretty much the same. Okay, and let's move on to. Okay, so obviously this is quotient rule. Still remember the quotient rule? Okay, so let's go back to the very beginning. Um, okay, so here's the quotient rules if you still remember. Okay, you need to recognize which is u, which is v, and that function must be in the form of u divided by v, right? Once it's in that form, then you can use the that's quotient rule. Okay, so normally because the quotient rule is quite bulky, bulky means you see the fractions and there are two derivatives. So normally we would prefer doing the derivative first, and then we just substitute the derivative into the form of quotient rule, right? Okay. Okay, so let's just try to get this done. Okay, the first one is fx equals e to the power x, 2x minus 3. So obviously I should define my u as e to the power x, and also my v is 2x minus 3. And we try to do the derivative. So for the first one, how about the second one? It should be quick. Okay, 10 seconds. 5, 4, 3, 2, 1. It's just 2. All right, figure out why. Okay, so let's try to do it in this case. Okay, see that's ex over 2x minus 3, right? Okay, so this is just in the form of u over v, so we can use our quotient rule. Quotient rule means you square the denominator, and you must differentiate the numerator first with the denominator next to it to multiply. That's derivative, and this is take away. It's not plus, and you swap the rows. Okay, and remember we've done the okay, so because you've done the derivative. Okay, and here you would like to okay, do some taking out common factors. Okay, so let's move it to the front to have 2x minus 3 minus 2. The 2x minus 3 square. And the 2x minus 5. And that's 2x minus 3 square. Okay, so that's it. Oh, good. All right. Okay, if you are okay with the previous question, I will ask you to spend 5 minutes on this one. Okay, you really need to try. Okay, try 5 minutes at least. Try to go as far as you can. I'm going to pause the video again. Okay, so I hope you've done it. Okay, if you haven't, spend more time. Okay, so this time I'm not going to write because I just feel a little bit tired. So I'm going to just show you the answer in my PowerPoint. Okay, oh, sorry. Sorry, I'm going to do it anyway. So because the one in the PowerPoint, I for I just forget it just come out as the whole answer. I try to show you step by step, which is much better, right? Like what we did in the lesson. Okay, so again, you need to define your u as that one, and your v is ex plus 1. So when you differentiate, let me change the color because there are two different colors there. Okay, so you try to do the derivative of u, and okay, so remember that's e to the power 2x. So for this part, you have to use that chain rule again. So still remember how to do it? You rewrite the whole function, then you multiply that 2. Okay, because they need to differentiate the power as well. So that's 6. All right, and how about the other one? So this one is much easier. Just itself plus 0. Okay, all good. And if you've done this too, and let me try to use them, of course, the quotient rule. Okay. Sorry, that u should be, sorry, 3 times e to the power. It's really difficult to see. Okay, and dv dx is just e to the power x, right? So let me just rewrite that as e to the power x over e to the power x plus 1, the whole thing square. And let me track a little bit. I need to see the whole picture, which is easier. Okay, I really don't want to make any mistake here. It looks all right. Yeah, it's okay. Okay, so then let's move on. Okay, so let's move on. So in the above, you will see that's a common factor right here. So, and that e to the power x is not, but e to the power 2x is. So I'm going to take that's e to the power 2x. And also that 3 and 6, I'm going to take out 3. So it becomes 2 times e to the power x plus 1 minus e to the power x. Okay. Plus 1 square, 3 to the power e to the power x. Okay, so that would be 2 times ex, 2 times 1 minus ex, e to the power x. Okay, so these two terms are like terms. Can you see that? So that means you can further simplify them. Okay, so some algebra to do. Okay, so this is the answer. Let me check with the PowerPoint. EX plus 2. Sorry. Yeah, it's correct. Okay, then that's good. Then we actually finish. Okay, then there are two practice. You have differentiation or exponential practice 1 and practice 2. So let me go to the PowerPoint. I will try to give you the homework. Okay, so the first part, I think I would like you to do question 1A, question 1D, and also I would like you to do 2A, 2D, to do 3A, find the gradient of tangent. Yep, then 4A. Okay, so these are the questions I would like you to do. And that's for practice 1. For practice 2, Porter rule and Quotient rule, right? I would like you to try this one and that one. And also, okay. Yeah, Quotient rule is pretty difficult. So how about I just do this one? Okay, and you have an answer as well, so you can check the answer whether you are correct. So there are 1, 2, 3, 4, 5, 6, 9 questions. Let's say you spend 10 minutes on each questions, and then there are 9 questions. Normally you will spend less than that. So even 10 minutes, 9 questions means 90 minutes, 1.5 hours. Okay, so 1.5 hours for this exercise. Okay, hopefully you can do them. Okay, after you finish, because we need to collect your homework, and you might hand it in the OneNote if you want, or you might just bring your homework back when we meet in during the. I don't think that's the third week or second week, but anything anyway. So just when we meet, you hand it in to me. Yeah. Okay. So I'm going to make possibly 2 more videos on the logarithm, and that's it. Okay. Hope you enjoy the videos and have learned something. If you feel you have some questions, please you can ask me in the YouTube. You can send me questions elsewhere. Okay. If you like the videos, just like it in the YouTube. And normally I don't have any likes. Okay. So okay. So hopefully you have a nice break again. See you later.